Alright, hey guys, it's Alex. Right now I'm going to be explaining the Coriolis effect. So the Coriolis force, it's a fictitious force that acts perpendicular to the velocity of an object in a rotating frame of reference. This force acts on objects that are in motion relative to the rotating Earth. The Coriolis force is not prominent on objects that are acting on the Earth's surface. However, it's noticeable in objects that move for extended periods of time above the Earth's surface, like aircraft. So the rotation of the Earth is essentially what's causing the deflection of objects in the air, right? And that is the Coriolis effect, essentially. Because the air movement on the Earth's surface is deflected due to the Earth's rotation, right? So we all know that the Earth is rotating, essentially, in a counterclockwise direction, right? So it's accelerating this way. That's the acceleration of the Earth, right? And this acceleration and this rotation is essentially going to cause objects that are in the Earth's atmosphere, above the Earth's surface, to deflect, because as these objects are moving freely above the Earth's surface, the Earth is moving to the east, right? In that direction. It's moving to the east under the object at a faster speed. Therefore, the example that I'm going to use is an aircraft in the Earth's atmosphere, right? So let's say I have this aircraft, and it's flying in the northern hemisphere, okay? So if it's flying towards the east, right? If you have an aircraft flying in the northern hemisphere, what's going to happen is the Coriolis force, it's going to act, it's fictitious, right? And it's essentially, due to the Earth's rotation, it acts perpendicular to the velocity of an object. So if I have an airplane moving at a velocity in this direction, the Coriolis force is going to act perpendicular to the aircraft, so it'll essentially be acting downwards. And what will happen over time is that, if left uncorrected, the aircraft will essentially deflect to the right, and interestingly enough, if it's not corrected for at all, this deflection would cause, over time, the aircraft remaining at a constant velocity to essentially rotate in a complete circle, right? Same thing said for the southern hemisphere, except the deflection, perpendicular deflection, would cause the deflection of the aircraft in the opposite direction. So the deflection would be coming from the south pole this time, and it would be causing the aircraft to kind of rotate in a counterclockwise direction. It's an interesting note, however, that an aircraft flying at the equator doesn't really experience the Coriolis effect, and that's essentially due to the fact that if you look at the Earth, it's circular, right? At the equator, it's a relatively flat kind of surface that it's going to fly around, right? The curvature is pretty minimal at the equator, which is why an aircraft flying along the equator won't really have to deflect. It will not deflect as a result of the Coriolis effect. Therefore, you don't have to correct yourself. It's also interesting to note that this is a fictitious force, right? The Coriolis force. And if you were someone that is on the Earth, that's why we have this force, right? Because on the Earth, you're essentially in that non-inertial frame because the Earth is rotating, although we normally think that the Earth itself is an inertial frame of reference. Looking at the Earth as a whole, you're on the Earth, you're now in a non-inertial frame, right? So because you're on the Earth, right, we could be in Mexico if we wanted to, we're just chilling right there. With the Earth rotating, you on the Earth, you don't really, unless, well, we know obviously that we're accelerating, but you yourself can't tell that you're accelerating, and therefore the deflection of the aircraft has to be blamed on the fictitious force that we now call the Coriolis effect, right? The Coriolis force. And that's why it's fictitious. Whereas if you were in space, like, an alien or anything like that, you'd be able to tell that, well, the deflection of objects in the Earth's atmosphere is due to the acceleration of the Earth, and therefore you wouldn't need this fictitious force to try and balance it out. So essentially that concludes the Coriolis effect, and hope everyone learned something from that.